right, so in this video, we're going to solve systems of inequalities graphically. So the same way we're going to graph these lines, we also graphed in the first 9 weeks. So let's go ahead and start. All right, so example 1, graph the solution to the following systems of inequalities. So first of all, we need to get these in slope-intercept form, y equals mx plus b. So I have, oh goodness, 5x minus 2y is less than or equal to 10. Okay, so I need to solve for that y. So I'm going to subtract 5x from both sides. What I do to one side, I also do to the other. That's the subtraction property of equality. So I'm going to bring down my minus 2y, negative 2y. It's less than or equal to negative 5x plus 10. Okay, and we want to get y by itself, so I'm going to divide both sides by negative 2. I'm going to divide every single term. That'll make it easier. Y, and since I divided by a negative, I need to reverse my inequality. So it's going to be greater than or equal to negative divided by a negative is 5 halves x minus 5. And that's my equation for my first graph. So let's go ahead and graph it down here. So I'm going to start with negative 5 because that's my y-intercept. And I'm going to graph my slope, which is up 5 over 2. Up 5 over 2. Up 5 over 2. If I could go up and right, I can also go down and left. Down 5 over 2. All right? And since it's greater than or equal to, it's going to be a solid line. So, oh, and I really want that to be red, not blue. Let's change that to red. Okay, start over. Okay, solid line. There we go. All right, and in this line, we are shading above. So I'm just going to put my little arrows right here. Okay, now for my second equation. I have 3x plus 2y is greater than 6. So to solve that for y, I'm going to subtract 3x. Bring down my 2y is greater than negative 3x plus 6. So I want to get that y by itself. So what I'm going to do is divide every single term by 2. And when I do that, my solution is going to be, my equation is going to be y is greater than negative 3 halves x plus 3. Okay, so let's graph that equation. I'm going to slide this down. I'm going to start with my y-intercept, which is 3. 1, 2, 3. And then I'm going to graph my slope. It's a negative slope, so I'm going to go down 3. 1, 2, 3, right 2. 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 If I could go down and right, I can also go up. 1, 2, 3, and left. 1, 2, 3, 1, 2. All right, and since that's a greater than, it's going to be a dotted line this time. So let's draw our dotted line. So right here. Okay, and as I'm looking at this, since it is greater than we're going to be pointing up top. So now you want to ask yourself, where do these two graphs overlap? This graph is going to be shaded right here. This is going to be your solution. Okay? Now remember, you can use Desmos to check these and make sure they're correct. However, I want you to know how to do these on your own. All right, so let's do the second one. So same thing. Start with solving your equation. So I have 4x minus 3y is less than 9. Okay, so let's solve this. 4x minus 3y is less than 9. Subtract 4x, so minus 4x, and I end up with negative 3y is less than negative 4x plus 9. Okay, divide every single term by negative 3. And what happens when we divide by a negative? We reverse our inequalities. Y is greater than 4/3 x minus 3. So y is greater than 4/3 x minus 3. So let's graph that. 4/3 x minus 3. So I'm going to go down 3, and I'm going to graph my slope. Since it's positive, I'm going to rise 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. If I could go down, up and right, I can also go down 1, 2, 3, 4. 1, 2, 3, and left. Okay, and that's as far as I can go. It's a greater than, so you know it's going to be dotted. So I'm going to draw my line. Okay, so there's our line. And it's greater than, so I'm going to shade up top. All right. Now for the second one. Okay, so let's go ahead and do the second equation. And I have x plus 3y is greater than 6. I'm going to solve for y, so I'm going to subtract x from both sides. 3y is greater than negative x plus 6. Divide every term by 3, and I have y is greater than negative 1/3 x plus 2. Okay, so let's go ahead and graph this equation. Y is greater than negative 1/3 x plus 2. So I'm going to start with my y-intercept, which is 2. I'm going to go down 1, right 3. Down 1, right 3. Down 1, 1, 2, 3. If I could go down and right, I can also go up and left. 1, 2, 3. Up 1, 1, 2, 3. Up 1, 1, 2, 3. That's as far as I can go. That's a greater than, so you know you're going to have a dotted line again. And let's make it match. Okay, so that is my second equation. And it says to graph above as well. So I'm going to draw my arrows. Then I'm going to ask myself, where are they all pointing? They're all pointing right here to this area right here. So this right here is my solution. It cannot be on the lines because they're both dotted. All right. Okay, so it can just be in the shaded region. So let's look at the third one. 4x plus 3y is greater than negative 6. So let's graph this. So I have 4x plus 3y is greater than negative 6. So I'm going to subtract 4x. And I'm left with 3y is greater than negative 4x plus 6. Oh, minus 6. Divide every single term by 3. I have y is greater than negative 4/3 x minus 2. And that's going to be a dotted line because it's greater than. So let's graph this. Y is greater than negative 4/3 x minus 2. So it's greater than, so that means negative 4/3. That means I'm going to go down 4. 1, 2, 3, 4 over 3. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. If If I could go down and right, I can also go up and left. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. Remember, I like to cover the whole graph, the whole coordinate plane. All right, so let's go ahead and draw this line. Okay, and once again, we're greater than, so I'm going to draw little arrows pointing up. And we're going to see where each one of my, because it's going to be shaded over here, so let's see where the second line is going to be shaded. X minus 3y is less than or equal to negative 9. All right, so let's graph this one. X minus 3y is less than or equal to negative 9. So subtract x. Negative 3y is less than or equal to negative x minus 9. Divide every single term by negative 3. And I have y. And since I divided by a negative, it's going to reverse my inequality, greater than or equal to 1/3 x. Negative divided by a negative is a positive, so plus 3. So I'm going to draw this line in this pretty purple. Okay, so I'm going to start with 3. 1, 2, 3. And I'm going to graph my slope. It's up 1, 1, 2, 3. Up 1, 1, 2, 3. Up 1, 1, 2, 3. If I could go up and right, I can also go down and left. 1, 2, 3. Down 1, 1, 2, 3. All right, and now I'm going to connect my dots. That's going to be a solid line because it's greater than or equal to. And I'm going to make it that pretty purple color. And let's do it. Ooh, that was not my line. I don't know why that. There it goes. All right. And for this one, we are told that it's shaded greater than or equal to. So I'm going to draw my arrows up. So we want to find where they are both shaded. And they are both shaded right here in this area. Now, the cool thing about one being solid and one being negative is all the solutions, all these ordered pairs are part of the solutions because they're on the, if they're on the solid line. These on the dotted line are not part of the solution. Okay, so let's go on down to example D. Graph the inequalities and determine whether the ordered pairs are parts of the solution. Okay, so let's start by graphing these ordered pairs. I mean, not the ordered pairs, the inequalities. Negative 3x plus y is greater than or equal to negative 2. So I'm going to add 3x. What I do to one side, I also do to the other because I'm an equal opportunity mathematician. Y is greater than or equal to 3x minus 2. Okay, so I'm going to graph that. Minus 2, rise 3. 1, 2, 3, run 2. 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 If I could go up and right, I can also go down and left. So 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. All right. And I'm going to graph that as a solid line because it's greater than or equal to. Right. And it's right here. Okay. And we are shading above. It's greater than, so we're shading above. So it's going to be up here in this region somewhere. Okay, so now let's graph the second one. Okay, so I have x plus 2y is less than 6. Subtract x. 2y is less than negative x plus 6. divide by 2, and I have y is less than -1/2 x plus 3. Okay, so let's graph this. 1, 2, 3, and it's going to go down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2, down 1, right 2. And if I could go down and right, I can also go up and left, up and left, up and left, up and left, and up and left. Okay, so that's less than, so that's going to be a dotted line. Okay, if you can't remember, refer back to your earlier notes on graphing inequalities. Okay, and here's this graph. So now we're going to plot the points. Well, we have to finish this one. We have not finished this one yet. It is said to shade less than. So I'm going to draw an arrow less than. My two arrows meet right here in this region. So that's going to be my shaded region. That's going to be my solution right here. Okay, now what I'm going to do is I'm going to plot all these points and see which ones are part of the solution. -5, 5. -5, 5. Yes, that's part of the solution. 0, 0. Yes, that's part of the solution. 0, 3. Right here. No, that's not part of the solution. So I can mark that one out. 1, 3. 1, 1, 2, 3. No, that's not part of the solution either. 3, 0. 1, 2, 3. Nope, not part of the solution. 0, -2. It's on the solid line. So yes, that is part of the solution. -4, +5. That's right up here. If you notice, -4, +5 is on the dotted line. So that is not part of the solution. Okay. And then we have -3, -7. So 1, 2, 3, 4, 5, 6, 7. Nope, that is not part of the solution either. So your answers are going to be -5, 5, 0, 0. And this would be like a TEI question where you would have to select all that would apply and be the correct answer. And those are the ones you would check. Thank you for watching.